problem, we want to find the angle between the vectors A and B. Okay, so this is a very simple question. So we are going to solve this using the definition for the scalar product or the dot product. Okay, so as we all know, given two vectors A and B, if we know the angle between the two vectors and we know the magnitude of the two vectors, then so if we know the angle between vector A and B and we know the magnitude of A and the magnitude of B, then the scalar product is defined as, so A dot B is equal to the magnitude of A times the magnitude of B and cosine of the angle between A and B. So in this case the angle is phi. Okay, so if you want to find the angle between A and B, it is this angle here, phi. So all we have to do is to make cosine of phi the subject in this equation. So we can write that cosine of phi should be equal to, so it should be A dot B all divided by the magnitude of A. Okay, so magnitude of A times the magnitude of B. Okay, so all we have to do is to find A dot B, and after that we find the magnitude of A and we find the magnitude of B, then we compute this expression over here, and after getting this result we take cos inverse of whatever results we get to find our angle. Okay, so let's do A dot B. So A dot B is equal to, so the vector A is 2I plus 3j. Okay, so 2I plus 3j plus 1k. Okay, so we are dotting this with vector B, which is negative 4I, okay, plus 2j minus 1k. Okay, so we know that, well, if you are doing the dot product, we have to multiply corresponding things. So we are going to have, so this will be equal to 2 times negative 4. Okay, so 2 times negative 4, then we have I dot I. Okay, then we have plus, so the next is 3 times 2. Okay, so 3 times 2 into 2, then we have j dot j, then the next is we have, so plus 1 into negative 1, then we have k dot k. Okay, now we know that I dot I is equal to, so I dot I is equal to j dot j equal to k dot k, and this is equal to 1. Okay, we know this. So what this tells us is that, so this tells us that a dot b will be equal to, so we have 2 times -4, that should be -8. Okay, that should be -8. I dot I is 1, so that goes away. Then we have 3 times 2, so plus 3 to 6. Okay, then j dot j is 1, so that is taken care of. Then we have 1 times -1, that gives us -1. So this will be equal to -6, sorry, -8 plus 6, that gives us -2 minus 1, so this will be -3. Okay, so the dot product between A and B gives us -3. Now the next thing we want to do is to find the magnitude of A and the magnitude of B. So let's do mod of A. Okay, so mod of A is equal to, so you know how to calculate the magnitude of a vector. That's very simple. So the magnitude of the vector is going to be, so we have 2 squared. Okay, so this is the vector A. The vector A is 2i plus 3j plus 1k. So we have 2 squared plus 3 squared plus 1 squared. And this should be equal to, that is square root of 14. Okay, square root of 14. And likewise, I calculate the magnitude of vector B. Okay, the magnitude of vector B is going to be, so that is also going to be square root. Then we have, so we have into bracket -4, okay, -4 squared plus 2, so 2 squared, okay, then plus we have into bracket -1 squared. Okay, so this will give us, so the magnitude of B will give us square root of 21. Okay, that gives us square root of 21. So now we can come back here and insert everything that we have done. So let's continue over here. So we can say that cosine of 5, okay, should be equal to, so A dot B, remember we calculated A dot B and we had -3, so we divide this by, so the product between the product of the mod of A, which is square root of 14 times, so times square root of 21. Okay, so this tells us that cosine of 5 should be equal to, if we do this on the calculator, we have -0.17496. Okay, so it means that 5 should be equal to cos inverse of -0.17496. Okay, 5 is equal to 100.07 degrees. So this is the correct answer, and this is how we solve this problem.